Construction 21, how to draw the centroid of a triangle. Before I do the construction, I want to explain a little bit about what the centroid actually is. So to do that, I'm going to draw a sketch of a triangle up here, like so, and if I've got A, B and C. So the centroid is the centre of the triangle where its centre of gravity would be. If you were to cut this triangle out of a piece of cardboard, the centre of gravity would be the point on which you could balance the piece of cardboard on a pencil. It's used in applied maths and sometimes it might be mentioned in physics class. So how do you get the centroid? The general idea of a centroid is to pick the sides and to get the midpoint of each side. So for example, if I get the midpoint between B and C, I get its midpoint, MP, and you would join it to the opposite corner, A. And you repeat that process for a different side. For example, you get the midpoint of A to C, the midpoint would be somewhere in the middle, and you'd connect that back to B. And likewise, you could do the same for the midpoint of AB, midpoint, and you would join that back to C. And it turns out that all three lines will meet at a centre called the centroid. So let's put this idea into practice here. So to get the centroid of this triangle, what I need to do is I need to work on one side at a time. I'm going to get the midpoint of B to C. Now, in order to get the midpoint of B to C, we use one of our early constructions, how to bisect a side. So to do that, I put my compass point at C and I extend my compass out more than halfway across. Like so, and you swing an arc like so. Now, keeping the radius exactly as it is, I'm just going to lift the compass and swap the point over to point B and swing an arc the other way. Now, you'll see that we get a point up here, which I can call point 1, and a point down here where the arcs cross called point 2. And to get the midpoint, I lightly connect 1 and 2 with a straight edge, like so. And where they cut B to C is my first midpoint. I'll call it midpoint. Now, that gets me my midpoint, but remember from our sketch, we get the midpoint here and then we join it back to the opposite angle, or the opposite corner, A. So I'm going to get this midpoint and I'm just going to line it up with a straight edge back to corner A, and I draw a light line this way, and I can extend it both ways like that. So that's one part of the construction done. I must do the exact same process now for another side. So for this one, I'm going to pick a B and I'm going to do the exact same construction. I'm going to bisect A to B, or find the halfway point. So I put my compass up at A and I extend my compass out a little bit more than halfway across and I swing an arc. Now, keeping the radius at the same length, I'm just going to swap it over to B, like so, and swing an arc the other way. Now, the tricky thing about these constructions is there's going to be a lot of arcs and a lot of lines on the same diagram. So you have to concentrate and you need to be very careful. So I'm just going to keep my finger on that curve there and where it cuts here. Now I'm going to mark this in as position 3. And if you just follow one of the curves around till it hits the other curve, just double check. It's this position here and that's position 4. Now what I'm going to do is I'm going to lightly join 4 back to point 3, and that gets me my bisector of the side. So this position here is my midpoint of A to B. So that point is halfway between A and B. Now, according to your sketch, you get the midpoint of A to B and you join it over to C. So I'm going to connect C back to this midpoint I just found, like so. And you can see that the line going from this midpoint to A goes along here and the other one goes along here, and they cut each other or intersect at here, which I'm going to call O. And that position there that I highlighted is the centroid of the triangle. And again, if this was cut out of cardboard, that would be the position where I could balance this piece of cardboard on a pencil tip or a pin tip. So there is the construction of a centroid of a triangle.